Hey, Steph, I just wanted to go through a couple things on the written homework for you to clear up a few things. Okay, so this was your problem. You ran everything correct in the applet to come up with the prediction line. But then when it says here, what is the predicted amount spent? Okay, so that's y. What is the y equal to when you spend 1.2 hours at the club? But it wants you to use this y hat as the prediction. What you did was you went up here and you found 1.2, and that's what someone actually spent. $38.90. So what it wants you to do is to use the regression equation to come up with that. So what that does would be y equals 21.85 plus 18.93 times x here, 1.2. So it wants you to calculate it, and that's where you would get 44.6. Okay, so when it says predicted amount, wants you to use this line that came out of the applet. That's one. All right. This one, so you must have put your data in Rossmann-Chance correct because you got the correct R value. Let me just pull up Rossmann-Chance here. I want to show you. So here's what is in Rossmann-Chance. You got the correct R value, negative 0.273. What you need to do is you need to come down and you need to select this regression table, right? Because we're doing a theory-based approach, we want to pull a t value from down here. We're always going to pull it from the explanatory variable column. So we want this 0.8. Then we come over here and let's see if I can make this bigger. Come over here, we can do both a theory-based and a simulated-based model. So we can put shuffle 100 times, but then up here, we want to select t statistic because we're using this t statistic to come up with our p-value. All right, then we're going to put it, I can't make this box bigger. We're going to put it in the, oh, here we go. We're going to put that t-value in the box. That's the thing we're testing. That's our statistic, our t statistic in this case. And we want this to be beyond because we're doing a two-sided test and it's going to come up with the theory-based p-value. I have a suspicion that you maybe did the simulated-based p-value, which would give you a slightly different answer. Okay, so that's what you need to do for this type problem. When it says theory-based, we're going to use a t statistic. All right, and let me go to the last one that you had. I actually ended up going back and giving you credit for this. It wanted it in context. So what you have here is correct. Every time x increases by 1 unit, y will increase by 0.17. What is x though? X is pounds, y is inches. So for each pound that goes up, height goes up by 0.17 inches. So when it's asking you to put it in context, you need to go back and in this case talk about pounds and inches. This is correct, right? But it's not in context. I did go back and give you credit. You'll see your average went up a hair. Okay, so again here, it says, what does the equation predict? So you got the correct equation out of Rossmann-Chance. This is correct. But what you did again was you looked up 170 pounds and you pulled the value here. These are actual values, not predicted values. Those are actual. You want to plug in this case, what does the equation predict for height? Okay, height is y when x equals 170. So you're just going to take your equation, you're going to substitute 170 in for x and calculate the predicted value, 65.53. Then to come up with a residual, all right, here is my actual value. When someone weighed 170 pounds, their height was 69.1 actual. The residual to calculate it is take your actual y value and subtract your predicted y value. So you're just going to take that 69.1. That's how tall someone actually was when they were 170 pounds. And then you calculated the prediction here, 65.53. The difference between those two, 3.57, is the residual.